2.0, getting ready. The slope of a line can be determined from the coordinates of any 2 points x1, y1 could be the coordinates of the first point, and x2, y2 could be the coordinates of the second point on a line. And I'm going to insert the little m here. The slope of a line m, that's the slope of a line represented by m, can be determined from the coordinates of any 2 points on that line. M is always equal to rise over run. And if we have 2 points, we can determine the rise by looking at the y values of those 2 points. And we can determine the run by looking at the x value of those 2 points. The rise ends up being y2 minus y1, so whatever the y coordinate is of point 2 minus the y coordinate, the value of the y coordinate at point 1, over x2 minus x1, and this will make more sense when we find a few examples. Let's see if we can do an example on this side. The example here is to find the slope of the line that goes through the points 4, 6. Finding the slope of the line that goes through the points 4, 6, and 12, 10. And again, to find the slope, all we need to do is find the difference in the y coordinates, which is 10 minus 6, y2 minus y1, over 12 minus 4. That's x2 minus x1. 10 minus 6 is 4. 12 minus 4 is 8. So the slope of the line that goes through 4, 6, and 12, 10 is 1/2. So if we were going to write that in the equation of the line, we don't know what the y-intercept is. We could figure it out, but this would be y equals 1/2 x plus b. That would be the equation of the line. We would have to still find the y-intercept, but we do know that m in y equals mx plus b is 1/2, just by finding the difference of the y coordinates and the difference of the x coordinates for our rise over run. Okay, a few notes on the equation of a line, and this should be review. So if at any point in time you have a line, if you know the slope and the y-intercept of a line, you can substitute these values directly into our formula for a line, directly into y equals mx plus b to get an equation for the line. Okay, so in this equation, y equals mx plus b, we know that the m is the slope and the b is the y-intercept. That means that tells us where the line is going to cross the y-axis. So if we had a line like this, then this y-intercept is right here. That's where it's crossing the y-axis, okay? And we would know the slope. This one looks like a slope of about -1 with a y-intercept right here, let's say at +1. If we have that information, we can plug it right into our formula here for the equation of the line. This little picture is just drawn for effect. Good. Now, if we don't know the y-intercept, but we do know the slope, so here we knew the slope and the y-intercept, a second case is if you know the slope and the coordinates of any point on the line, any point on the line, substitute this information into our formula y equals mx plus b and solve for b to find the y-intercept. For the second one, yep, so this goes right underneath. So let's say we had the equation of our line, which is y equals mx plus b. We know that the slope is 1, and we know that it goes through the point 2, 1. We can use that information to solve for b. If we can solve for b, then we get the general equation for this line. Okay, so we can do that. This is telling us that m equals 1. So over here, I just have x with a imaginary, not imaginary, an invisible 1 in front of it. I don't need to write it if it's a 1. I know I have 1x plus b. But I also know that x is 2. At some point on this line, x is 2 and y is 1. So I can sub in those points. This is a 1. Yeah, y has a value of 1 when x has the value of 2. The m hasn't gone anywhere. The m is still there. It's 1. 1 times x is x, right? 1 times 2 is 2. And so now all I have to do to find b is subtract 2 from both sides. And I end up with b equals -1, which tells me that the equation of the line that has a slope of 1 and goes through the point 2, 1 is y equals x minus 1. This line has a slope of 1 right here, and it goes through the point 2, 1. Okay? Last note. I can just use. If you know, so this time you aren't going to know the slope, you're just going to have the coordinates of 2 points. So if you know the coordinates of 2 points on the line, on a line, you can use these 2 points to calculate the slope of the line. So if you know the coordinates of 2 points, you don't know the slope, you don't know the y-intercept, but you know that a line goes through these 2 points, you can use those 2 points to calculate the slope. And that's what we did in our first example with the slope of a line. Okay? Good. Parallel lines. Let's review parallel lines. What has to be true if a line is going to be parallel to another line? Has the same slope. Okay? Does it also have the same y-intercept? No, it's going to have a different y-intercept. If it had the same y-intercept, it would be the same line, right? If it had the same y-intercept and the same slope, we would call it coincident, right? It would be the same exact line, but it does not have the same y-intercept. I can demonstrate that just quickly. So here we have our coordinate plane. We have a line that goes through with that kind of slope, okay, -2, and a line parallel to this will have the same slope, but look at what happens. It goes through a different place on the y-axis. So they have different y-intercepts. If they had the same y-intercept, it would be the same line, okay? And then it would be called coincident, not parallel. Does anybody remember how to find the slope of a line that is perpendicular to a given line? Does anyone remember how to find the slope of a line that is perpendicular? So let's say we had the line y equals 6x plus 5. What could a line be? This has a slope here, so y1 is the line 1. That means m1 is 6. So the slope of the first line is 6. How would we find a slope that is perpendicular to 6? Pardon? There is a line that is perpendicular to this line. So we need to think about what is the slope of that line. So this one, the slope is kind of like 6 is pretty strong. So the line that would be perpendicular to this would kind of have a slope like that. The second one's better than the first one. So somebody give me something that's true about this second line. Well, they're going to intersect each other eventually because they're two different lines, and two different lines will always intersect unless they're parallel. But this slope was very, very steep, and it was positive. The slope of line 2 is slightly negative, like Stephanie just said. Well, it is negative, and it's not as steep. It's actually pretty close to horizontal, isn't it? Okay. So I'll just show, if we wanted to find a line that is perpendicular to this, we need this note. The slopes of perpendicular lines are negative reciprocals of each other. So that means that M2, that's the slope of the second line, is going to be the negative reciprocal of M1. Okay, so a reciprocal means you just flip the fraction upside down, and opposite or negative means if it's a negative slope, you put a positive in front. If it's a positive slope, you put a negative in front, okay? So that tells us here, we'll go back up to our example. We have given a slope of m equals 6. Well, this is the same as 6 over 1, right? So m2, in this case, the perpendicular line, would have a slope of, this is positive 6, so we would be looking at negative 1 over 6. Okay, that is the opposite. It was positive, we switched it to negative, and it was a reciprocal. Instead of 6 over 1, we have 1 over 6. It's an opposite reciprocal. Our book calls it a negative reciprocal. Okay, negative might get you confused. Just if you're already dealing with a negative, you'd have to do negative and negative, which is a positive. If you call it the opposite reciprocal, then you know right away, every time it's negative, I'm going to go positive. Every time it's positive, I'm going to go negative. Okay, so what's really happening is that it's a negative reciprocal, but an easy way to remember that is I'm just going to, no matter what I get, I'm going to switch the sign. Okay, I'll show you one more. We need to find the line. So that means there's going to be two lines. One of the lines is called line 1, One of the lines is called line 2. This is the slope of line 1, and this is the slope of line 2. Okay, so whenever you're dealing with multiple lines, just like we had y1, y2 before, x1, x2, so whenever you're dealing with multiple of the same variable, but you're dealing them within different lines, you call them line 2 and line 1.
Is that 5 up there where you put the thing on the y?
Yep, so this would be the y-intercept. Now a perpendicular line, I could have any y-intercept in the whole world. As long as it has an opposite reciprocal slope, I know that wherever it hits line 1, it will be perpendicular. This one? That was just any old line in the whole world. Well, it's called y1, and the slope is 6. So all I did was I said, okay, we have this equation, line 1, the slope of that line is 6. What is the slope of a line that is perpendicular to this line? If the slope here is 6, then the next line has to have a slope of negative 1/6, and then they will be perpendicular. So this y2 is anything that has a slope of negative 1/6. Could be +2, could be -1,000, doesn't matter. I know that it's going to hit line 1 and it's going to be perpendicular. Okay, as long as the slopes are opposite reciprocals. And we can do a couple examples of that as well. So find the slope of a line perpendicular to y equals negative 4x minus 7. All right, so we've got this line, y equals negative 4x minus 7. So the first thing I want to do is identify the slope of this line. Nadia, what is the slope of this line? The slope is negative 4. Okay, all we have to do is take this m value. Slope is negative 4. And I need the slope of the line that is perpendicular to this line with an opposite reciprocal slope. Amy, what is the slope of our perpendicular line? Good job. Okay, so negative 4 is the same as negative 4 over 1. So all I have to do is switch the sign from a negative to a positive and flip my fraction, 1 over 4. And we don't have to come up with a whole equation for the perpendicular line. We just have to come up with the slope. If we did have to come up with an equation, it could be any equation of a line in the whole world as long as the slope was positive 1/4. And it would be perpendicular to our given line. Similar geometric shapes have this, they're not shapes. We're calling them figures. Similar geometric figures have the same shape but differ in size. They have different sizes. Congruent geometric figures have exactly the same shape and size.